As you have studied earlier about the total internal reflection, in this video lecture we are going to cover applications of total internal reflection. The applications we are going to cover are total internal reflecting prism, optical fiber, light pipe, and endoscope. The first application is totally internal reflecting prism. Students, we are going to talk about two types of totally internal reflecting prisms. The first one is the right angled prism. Many optical instruments use right angled prisms to reflect a beam of light through 90 degrees, such as cameras, binoculars, periscope, and telescope. One of the angles of a right angled prism is 90 degrees. As you can see in this figure, one of the angle is 90 degrees and the other two are 45 degrees. When a ray of light strikes a face of prism perpendicularly, it enters the prism without deviation and strikes the hypotenuse at an angle of 45 degrees. How I am saying that it will strike at hypotenuse at 45 degrees? If you draw a normal to this surface, to this hypotenuse, you can see that this light ray is striking the hypotenuse at 45 degrees. And since the angle of incidence is 45 degrees and it is greater than the critical angle of the glass is 42 degrees, the light is totally reflected by the prism through an angle of 90 degrees, right? And two such prisms are used in periscope. So this is the application of total internal reflection through right angled prism. Total internal reflection through isosceles prism. Students, you can see here that besides a 90-degree deviation, an isosceles prism is used to produce a 180 degrees deviation, but you can see that this time reflection occurs on the equal adjacent sides of the prism and not on the hypotenuse. You can see here that deviation is 180 degrees and reflection is occurring from two adjacent sides of the prism. It is not from hypotenuse. So two such prisms are used in binoculars, and this is also the application of total internal reflection. Optical fiber. It is an application of total internal reflection. Fiber optics or optical fiber are long, thin strands of very pure glass about the diameter of a human hair. And it has number of advantages like in telecommunication field. You can see the passage of light through prism in this figure. As I have told earlier that fiber optics consists of hair-sized threads of glass or plastic through which light can be traveled. Let's see this figure in detail. Look at this. This is the inner part, and this inner part of the fiber optics is called core, and this part basically carries the light, and the outer shell, this concentric outer shell, is called cladding. This inner part, which is called core, is made from glass or plastic of a relatively high index of refraction. The cladding is made of glass or plastic, but the relative index of refraction or refractive index of this cladding is relatively low as compared to the core. And you can see in this figure that light entering from one end of the core strikes the core cladding boundary at an angle of incidence greater than the critical angle and is reflected back into the core. And in this way, light can travel many kilometers with small loss of energy. And in Pakistan, optical fiber is being used in telephone and advanced telecommunication systems. Pipe. Students, it is another application of total internal reflection. Light pipe is basically a bundle of thousands of optical fibers bounded together, and they are used to illuminate the inaccessible places by the doctors or engineers. For example, doctors can view inside of a human body, and they can also use to transmit images from one place to another place. Endoscope. An endoscope is a medical instrument that is used for detailed diagnosis of a disease, and a medical procedure using any type of endoscope is called endoscopy. Basically, the light shines on the organ of patient to be examined by entering through one of the fiber tubes of the endoscope, as an endoscope uses two fiber optic tubes through a pipe, and then light is transmitted back to the physician viewing lens through the other fiber tube by total internal reflection. Basically, an endoscope is used to explore the interior organs of the body, and due to its small size, it can be inserted through the mouth and thus eliminates the invasive surgery, as you can see in this figure. Refraction through prism. This is the last topic of this week. In order to understand refraction through prism, Students, you have to consider this figure. Basically, a prism is a transparent object with at least two polished plane faces inclined towards each other, from which light is refracted. In this case of triangular prism, as you can see in this figure, the emergent ray, this is the emergent ray as it is emerging from prism. This ray is not parallel to incident ray. If you extend this ray in the backward direction, you can see that this is not parallel. This is the incident ray, and if you extend it in the forward direction, you can see that these two, incident ray and the emergent ray, they are not parallel to each other, but it is deviated by the prism from its original path. As this is the incident ray and this is the emergent ray. The incident ray, let's suppose we have incident ray PE, makes an angle of incidence I at point E and is refracted towards the normal. As you can see that this incident ray is entering from air to a denser medium, which is a glass prism. It is deviated or it is refracted towards normal, and this is the normal to this face, and it will deviate towards normal as light ray enters from rarer medium to a denser medium, as you have studied in refraction of light. And when this ray is emerging from this side of the prism, it is basically entering from a dense medium to a rarer medium. It will bend away from the normal. This is the normal to this face. It will bend away from the normal. This ray emerges out from the prism at point F, making an angle E, which is the angle of emergence. Hence, you can see that the emerging ray Fs is not parallel to the incident ray, that is PE, but is deviated. If you extend it and you extend this incident ray, you can see there is an angle which is angle of deviation. So the emergent ray is not parallel to the incident ray but is deviated by an angle D, which is called angle of deviation.